When building applications, it often needs access to different configuration, be it a connection string, a client ID or a secret, an external API URL and a token, etc. By keeping these values in the application's configuration, we can use different values in different environments. ASP.NET Core provides a rich support for adding various configuration sources, including the app settings, the environment variables, key vault, and many more. We learned how to integrate with these different sources in a different video about configuration, which is linked here and in the description below. In this video, let's learn how to consume these configurations from the application code you write using the options pattern in ASP.NET Core. Hello everyone, my name is Rahul and welcome back to my YouTube channel. In case you are new here and want to know more about me, check out my blog, which will be linked here. I recently started a newsletter which you can subscribe while you're on the site. And please don't forget to subscribe and help me grow this YouTube channel. Let's head off to the console and create a new .NET Web API application. I'll use the .NET CLI and use the new and the Web API to create a new template. This will create a new application in the current folder. Let's open this in an IDE of your choice. I will use Rider for this example. Since I have linked it with my command line, I can use Rider 64 and dot on this folder. This will open the newly created project in Rider. By specifying dot, it will open up the current folder and the associated projects in Rider. Here, I have the Web API template opened up in Rider and it has a program.cs, the startup.cs, and a default controller, which is the weather forecast controller. This controller currently hardcodes the data which is getting returned on the get call. Let's modify this code to talk to an external API. Let's clean up this class to start with. So let's remove this hard-coded data and also this method that returns the dummy data back. Let's take in a city name, which is where we are going to expose the values, and give it a default value, and let's say Brisbane, which is the current city that I'm right now in. Instead of returning an enumerable of weather forecast, let's simply return a task of string, which will be the JSON response from the external web API. To talk to an external API, let's inject an HTTP client factory to create an HTTP client. So let's name this HTTP client factory and make sure to create a read-only field in this class. I have some code already written out to talk to the external API, so let me paste that in here and walk you through it. I have the external API URL, which is the api.weatherapi.com. It uses a secret key to talk to the API and also passes in the city name, which is a queue parameter in the API URL. This city name is currently coming in as a parameter to our API method. We use the HTTP client factory to create a new client and we have wrapped it in a using statement. Let's make sure to add async in here so that this await call returns as expected. To learn more about how to use an HTTP client and what the good practices around it are, check out my video on that linked here or in the description below. Using the HTTP client factory is just the starting process in that, but I'll stick to that to keep this simple. To make sure the HTTP client factory gets injected into our controller, let's go to the startup.cs class and add in the support for that. Under the configure services method, we can register in the dependencies that this application needs. So here we can say services.add HTTP client. This will register for the HTTP client factory. Let's run this application and make sure it works as expected. The application is running as expected and it returns back a string JSON, which is the weather for the default country that we gave, Brisbane. We can pass in additional properties in here, but let's keep it like this for now. Let's refactor this code to extract this URL into an application configuration. To start with, let's extract this part as a base URL. So let's name this as base URL and give in the value that we just copied, which is the value to the URL to the API. Since I have the string interpolation already here, let's use the base URL to specify that value now. This key definitely can also go into a configuration. So let's copy that and name this as key. So let's give that value and make sure to use this inside the URL that we are constructing. So let's give it in the appropriate place and call this key. Now we have this URL getting constructed of a base URL, the key, and the city name, which is coming from the API parameter. We can now extract these two values, the base URL and the key, to the application's configuration. So let's open up the Explorer and go to appsettings.json. In here, let's add in a new section for the weather API. So let's specify weather API and give that as an object. In this case, it's going to have the URL as a property and also the key, which is going to be the API key. So let's go back and copy these two values from here. So let's copy that from here and put this into the URL. Similarly for the key. So let's use that and specify it in the key part. Now we have extracted these two values into the application's configuration. The easiest way to consume this config is to use the iConfiguration interface. If we go to the startup.cs class, you can see an iConfiguration getting injected into the constructor. Similarly, we can inject this into the weather forecast controller as well. So let's go back to the weather forecast controller. After HTTP client factory, we can inject in an instance of the iConfiguration. Let's add in the relevant usings and name this configuration. To use this, let's make sure to have a read-only field and starting use the iConfiguration to get the values from the config. Let's now use the configuration to retrieve value from the configuration source. In this case, the appsettings.json file. To get a value, we can use the underscore configuration and use the getValue method in that. Since we know that it's a string, let's specify it as string. For the key, let's use this section value and specify a colon to separate the hierarchy. So it will be weather API :URL. Similarly for the key, let's use weather API :key. So this is going to retrieve the value from the configuration interface that gets injected into the controller. Let's run this application and make sure it's working fine as expected. The application is running fine as before and we get back the JSON value for the city Brisbane. The API key in here, which we have specified in the appsettings.json, is a sensitive information. Normally, I wouldn't put that in the appsettings.config as a plain text. A better place would be to use key vault, which I have covered in a separate video. For this video, to keep things simple, let's leave it in here and move on. Injecting in the iConfiguration into the controller is a bad design pattern. It is very similar to the server's locator pattern, which is often considered as an anti-pattern. Looking from the outside, there's no way to tell what configuration values that this controller now depends on. All it takes is an interface of iConfiguration, which has all the config values inside of it. And also, the controller class is now tightly coupled to the way the config object is structured. It needs to know that there is a weather API section. It has to use a colon to separate for hierarchy and also specify the properties that's required for the URL and the key. So this controller is now tightly coupled with the configuration and the way it is structured. Let's see how we can fix this using the options pattern available as part of ASP .NET Core. The options pattern is an extension on top of the iService collection and provides a way to access group of related settings. It uses strongly typed classes to represent config values. Let's see this in action. To start with, let's create a new class to represent the config values for the weather API. Let's name this weather API options. I'm using options here just for conventional purposes. You can name this as you want. We have two properties, the URL, which is of type string, and also a key, which is also of type string. So let's create those two properties inside of here. For the section name in the config, we can choose to keep it here so that we don't have to hardcode it anywhere else. So let's create a constant string and call it weather API. So this is equal to the section that's there in the appsettings.json, which is again weather API. So let's specify that along with the options as well. To start using this newly created class in the weather forecast controller, let's inject in an IOptions of the new class that we just created. In this case, weather API options. So we can name this as weather options. Make sure to include the relevant usings, which is the Microsoft extensions.options in this case. Let's save the weather options to a private field. So let's specify underscore weather options and give in the weather options dot value, which is of type weather API options. So let's save that. Create this new field, weather API options, and start using that inside our controller class. So instead of underscore base URL getting from the configuration value, we can use underscore weather options and specify the URL from here. And also in here, instead of the key from the configuration, let's use the weather options.key. So now we have both the values getting injected in using the options pattern. To dependency inject the weather API options using the options pattern, let's use the services and specify the configure method. Here we need to specify a type, which is the weather API options. Since this value is coming from the configuration, let's use the injected in iConfiguration instance to retrieve that value. So specifying configuration.getSection. So we have the section name inside our weather API options class. So let's use that to retrieve that particular section. In this case, the weather API. So this is going to read the values from the section weather API from the appsettings.json file and register it as an IOptions of this particular class. Let's run this application to make sure it's working fine as expected. The application is running successfully and it returns us back the data for Brisbane as we have specified. An options class must be non-abstract. It should have a public default constructor. All the public read-write properties are bound to the configuration value and the field values does not get bound, like the weather API string that we added in the class. Applications that we write often talk to multiple services, including a database, an external API, like in this case, an authentication service, etc., which all needs different forms of configuration values. It's a good practice generally to keep these settings grouped and separate from each other, which means we will have several different classes like the weather API options that we just created now. By doing this, the app adheres to two important software design principles. The interface segregation principle, which means the classes that depend on the configuration settings depend only on the settings that they use. And also separation of concerns, which means the different parts of the app does not use the same configuration and are not coupled with each other. Everything is working fine, but let's say we need to update the API key of this weather API. So let's head off to the weather API dashboard. I have used the weatherapi.com API for this example. So let me regenerate this key. So let's say I agree and regenerate the key. So I have a new key. So let me copy that and update the appsettings.config. We still have the application running, but let me update the app settings right away and save this. Let's come back to the API and make a new request. To make sure the request doesn't get specified from a cache, let's specify a city name. So in this case, let's give in London. This request now fails with a 401 unauthorized. This is because we have changed the API key. However, the application did not pick this up, even though we updated the appsettings.json. To get this to working, for now, I'll have to restart the application so that the app settings will again be refreshed. I definitely don't want to restart the application to update the API key. So let's see how we can fix that. The options pattern supports multiple interfaces. In the weather forecast controller, we used the IOptions interface. As you can see, the IOptions interface does not support reading the configuration data after the app has started. It is registered as a singleton instance, which means once the application starts, it's going to have the same value even if we update the values in the configuration. If we want the values to be recomputed on each request, what we need to use is the IOptionsSnapshot. In this case, the options value is recomputed on every request. It is registered as a scoped interface, which means we cannot use this from a singleton service. However, in our case, the weather forecast controller is not a singleton service. So let's see if we can use the IOptionsSnapshot. Let's go back to the weather forecast controller, and instead of injecting the IOptions, let's inject in the IOptionsSnapshot. It has a value property on that interface as well, so the rest of the code works as expected. Let's run this to make sure it works as we want. The application is running and it is getting back the value as expected. Let's go into the dashboard again and regenerate this key as before. It has created a new key for us, so let's copy this value. Before updating the value in the app settings, let's go back to the API and make sure a request fails. So let's specify a city name and specify, in this case, Sydney, to make sure it doesn't get served from the cache. Since the API keys are now updated, it returns an unauthorized. So let's go back to the application settings and update this value in here, which is the new API key that we just regenerated. So let's save this. This should trigger an automatic reload from the next request. So let's go back and refresh the request to Sydney. Now you can see the application is working as expected. I did not have to restart the application to have the changes to the app settings reflected. This is because we used the IOptionsSnapshot. Note that the IOptionsSnapshot works only with configuration sources that allows reloading of the data. If we navigate to the program.cs class, we can see the host.createDefaultBuilder. This is where the appsettings.json is getting registered. If we go into the definition of this method and scroll down, we can see the add.json file request to the appsettings.json file. We can also see that this is specified to be reload on change. This is why the configuration values is getting updated anytime we make a change in the config file. So if you are depending on the IOptionsSnapshot, make sure the configuration source that you use also supports reloading on change. With the options pattern, we are binding a strongly typed classes with the values in the JSON file. A lot of things can go wrong with this. Let's see a few examples. To start with, if the section name that we specify in here does not match with the values in the appsettings.json, let's see what will happen. So we have the application still running. So let's make a change in here to add a typo. So let me add an extra I and go back to the application and refresh it. Since we are using IOptionsSnapshot, it will reload this new section for the new request. So let's refresh this. And here we see that the URI is invalid and a base URI address must be set. Let's add a breakpoint to the weather forecast controller to see what is happening. Let's go back and refresh this request again. And here we can see the weather API options is now returning null values for both the key and the URL. This is because it does not find a matching section in the appsettings.config. Similarly, let's fix this API section. If one of the values is wrong, let's say the URL has a typo, and if you refresh this request, this is going to be the same. So in here, the weather API options successfully binds to the key property, however the URL is still null. So any mismatch with the sections or the property names gives it a default value. The options class can also have types other than string. So let's stop this application, go back to the weather API options. Let's add a new integer property. Let's call this count for example. Go back to the appsettings.json file and add in a new value for count. So let's specify 12. Let's make sure to fix the URL property and run this application to make sure it's working as expected. The application is running and it makes a new request to this API endpoint. Here we can see that we have the count property getting applied correctly. So it's automatically binding the type to an integer property in here. If this type had an invalid value, let's say we give it as invalid, which is definitely not an integer. So let's save this and make a request again. This now throws an exception. So when it's trying to create a weather API options and try to convert the count property to integer, it says it cannot convert it and that the input string was not in the correct format. Let's revert this back to a valid value, in this case 12. We can also add validation attributes to the weather API options. So if we want to specify that this URL is required, we can use values from the data annotations library. So let's specify required, which is getting imported from the systems.component model.data annotations. We can specify the same for key as well. We can also use the other classes from the annotation libraries like range, which specifies a range of values that this property can take. So let's say it can be anywhere between 10 and 100, for example. To enable this data annotations library, we need to come back to the startup.cs and slightly change the way we configure the API options. We can use the services.addOptions method. So this also takes in a type. So here we can say weather API options. Let's bind this value first to the configuration section. So let's use bind and specify the configuration.get section as before, and also specify the weather API options.weather API. To enable the data annotations that we added on the class, let's specify the validate data annotations method. So this is going to make sure those annotations are getting evaluated. Let's run this and make sure everything is working as expected. The application is running and it returns back all the value as expected. Let's go back into the appsettings.json. And now let's say if we have a typo in here for the URL property and save this and run this again, it's now going to throw an error. It says the URL field is required. This is because of the data annotations property. So it's no longer making a request to the external API and saying it is an invalid URL. It explicitly says even before saying that this property is required. Let's fix that back and give a count which is a less value, let's say 1, and we had specified it to be a range between 10 and 100. So let's run this again, and this is going to now say that the count must be between 10 and 100. You can also use other data annotation attributes, including regular expressions, to validate these properties. For more complex validations, you can use an IValidate/options interface and write your own custom validations. Check the description for the link to the documentation. I hope this helps you to understand more about the options pattern in ASP.NET Core and how to use it to get configuration values in your application code. The options pattern helps to keep the code clean and well separated. It also supports additional features like automatically reloading of the configuration values as and when they change. If you like this video, please make sure to hit the like button. And if you want to be notified in the future of similar such videos, please make sure to hit subscribe. Thank you and see you soon.